Hi, I'm Cassie, and I'm going to walk you through question 44 of the AAMC's official physics question pack that prepares you for the MCAT. So this question is still related to passage 7, and it's all about testing your understanding of how charged particles interact. So let's break it down. We're told in the question that we place a small negatively charged particle next to a fixed positively charged particle. Say this is our positively charged particle that we're calling Q. And we want to know what happens when we do that. Is our negatively charged particle going to move towards Q? Is it going to move away from Q? If it moves towards or away, is it going to do so at a constant speed or accelerating? So you should always ask yourself what kinds of concepts and equations apply here. Well, we have two charged particles, and we know that Coulomb's law describes the relationship between two charged particles. So let's go ahead and write that out. Coulomb's law says that the force between two objects is equal to K, which is just a constant, times the absolute value of the magnitude of the two charges. So we'll say charge 1 is Q1, so that could be like our negatively charged particle here, and charge 2, which we'll call Q2, that could be like our positively charged particle here. So the absolute value of that, all divided by the square of the distance between our charges. And then the other equation that's going to apply here is that of Newton's second law, which you should always be thinking about with whether things accelerate, because Newton's second law says that force equals mass times acceleration. So we could go ahead and solve for acceleration here, and we get acceleration equals force divided by mass, and then we could plug our Coulomb's law, which quantifies, the magnitude of the force between two charged particles, into our Newton's second law equation, solve for acceleration. So let's go ahead and do that. So that would give us that the acceleration between two charged particles would be equal to K times Q1, Q2, divided by r squared, all divided by mass. And remember, when we divide by something, it's the same as multiplying by its inverse. So I'm just going to go ahead and skip that step and multiply by its inverse here, 1 over m. So what is this equation telling us? It's telling us that the acceleration of a charged particle is going to depend directly on the magnitude of our charges, because they're in the numerator of our equation, and the acceleration is going to depend inversely on the distance between our charges and the mass of the negatively charged particle. Okay, so that was a quick review of our relevant equations here. Now let's just think about the concept. So we know that there's a force at play here, right? There's always going to be a force between opposite charges. And therefore, if we have a force at play, we know we're going to have acceleration. So we have acceleration, and then we just have to decide which way is our acceleration going to happen. Well, we know that opposites attract. So that negatively charged particle, it's going to go towards our positively charged particle. So our answer here is answer choice B for me, which is that negatively charged particle is going to accelerate towards that positively charged particle. Now, I would take a second here to go back and review question 27, so an earlier question of the physics pack, because question 27 is asking something very similar. It's about the photoelectric effect, and it's saying when an electron, so a negatively charged particle, gets ejected from a cathode, what happens in terms of its movements toward the anode? And the same thing is going to apply there. That electron is experiencing an electrical force, it's in an electrical field, and so that electrical force is going to accelerate it toward the anode. So this kind of theme of charged particles and their acceleration keeps coming up in the physics question pack, and that means you definitely want to have this down. So I hope this helps. If it helps, please give this video a like and follow my channel for more content like this.